Welcome to this explainer. Okay, we've got to dive right into this massive coordinated announcement from NVIDIA and Microsoft because it just signaled a profound reinvention of the PC industry coming in 2026. We are looking at a fundamental ground-up architectural departure from the devices we've all used for decades, and it's all being driven by a brand new piece of silicon, the RTX Spark. To really wrap our heads around this massive philosophical shift, just look at this bold claim from NVIDIA's CEO Jensen Huang. He makes a great point. For 40 years, computing was all click and type. You, the user, did all the heavy lifting. But with RTX Spark, the idea is that you simply ask, and the PC actually does the work for you. The entire goal here is to transform the computer from a passive tool into a proactive teammate. Here's our roadmap for today. We'll start by looking at reinventing the personal computer. Then, peek inside the RTX Spark Superchip, explore the shift from apps to AI agents, break down the impact on creatives and gamers, and finally, look at the real-world challenges for this new era.
All right, let's jump straight into part one, reinventing the personal computer.
Think about the different computers you've owned over the years. We've evolved from those bulky, modular x86 machines back in the 1980s all the way to the highly portable touch interfaces of our smartphones and tablets in the 2010s. And just recently, in 2024, Copilot Plus AI PCs basically tacked AI processing onto existing hardware. But 2026? It's fundamentally different. The RTX Spark marks the very first time an entire system is being built around AI directly from the silicon up. It completely reimagines your daily driver. So, how are they doing it? Let's move to part two, inside the RTX Spark Superchip. Under the hood, this thing is an absolute beast. It fuses a custom 20-core ARM-based CPU with a Blackwell-architecture GPU into one incredibly efficient package. We're talking over 6,000 CUDA cores here. But here is the real kicker. This isn't designed for some massive, noisy desktop tower. Thanks to an ultra-efficient 3-nanometer class manufacturing process, all of this power is specifically engineered to fit right into premium thin-and-light laptops, literally devices as slim as 14 millimeters that weigh just 3 pounds. But honestly, the real magic here is this: 128 gigabytes of unified memory. In a traditional PC, you know how your CPU and GPU have separate memory pools? Well, that creates a massive bottleneck, like a huge traffic jam, because data is constantly being copied back and forth between them. This unified memory approach completely eliminates that bottleneck. Both processors can instantly access the exact same data, which just drastically speeds up those complex tasks. And because of that architecture, it unlocks an absolutely staggering 1 petaflop of AI performance. To put that into perspective for a second, a few decades ago, you'd need a supercomputer the size of a tennis court to hit those numbers. Now, it's just sitting quietly on your lap. It allows you to run massive 120 billion parameter language models entirely locally. That means no cloud connection needed, 0 subscription fees, and your processing happens right there on your desk, keeping everything incredibly fast and, most importantly, entirely private.
Which perfectly sets up part three, from apps to AI agents. This right here is the real behavioral shift. It marks the end of the manual cognitive load we've all just sort of accepted as normal. The old way meant you had to be the conductor. You open the spreadsheet, you copy the data, you format the presentation all by yourself. It's incredibly manual. The new way relies on agentic AI systems. You basically get a digital teammate that executes complex tasks autonomously based entirely on your high-level instructions. Let's look at a concrete example of this workflow. You literally just state your objective to the computer, hey, create a quarterly business review. The agent takes over from there. It retrieves your local data and analytics, generates the visual charts, and completely formats the slide deck. It'll even write out your speaker notes for you. So instead of spending 3 hours jumping between 5 different apps doing these micro tasks, you spend maybe 3 minutes just supervising the output of a highly capable local agent. It's wild. Now, I know what you're thinking. Giving an AI that much access to your files and workflows raises a massive security question, right? Well, that's exactly why Microsoft and NVIDIA developed NVIDIA OpenShell. It's a secure runtime environment that operates strictly under your user-defined policies. Your identity is fully protected and your private workflows stay locked down on your actual device. It only routes queries to the cloud when it's absolutely necessary and explicitly approved by you. Okay, let's look at who benefits the most in part 4, impact on creatives and gamers. The creative industry is already adapting to this massive leap.
I mean, Adobe is actively re-architecting flagship apps like Photoshop and Premiere Pro specifically for the RTX Spark. Because of that massive 128 gigabytes of RAM we talked about, video editors can actually hold entire 8K or even 12K video projects entirely in memory. You can officially say goodbye to those agonizing rendering queues. And for the gamers out there, you're getting AAA console-level gaming at 1440p right on an ultra-slim laptop, complete with deep integration of DLS upscaling and real-time ray tracing. But beyond just the visuals, all this AI horsepower opens the door for fully dynamic world building and genuinely intelligent AI companions right inside the games.
Let's keep things balanced, though. Part 5. Challenges for the new era. Look, a paradigm shift this big won't happen without some friction. First up, there's early software compatibility on this new ARM architecture to worry about. Then there's the cost. Packing 128 gigabytes of unified memory into a premium tier is undoubtedly going to come with a pretty high price tag. Plus, you have the actual physics of managing thermals and fan noise inside a tiny 14mm chassis. They also face a real battle to secure vital developer mindshare away from established x86 platforms, not to mention the constant need to guard the expanding attack surfaces created by these autonomous agents.
So all of this begs the question, is this really the end of the traditional PC? Well, while traditional x86 machines have decades of enterprise momentum behind them and definitely aren't disappearing overnight, this bold new silicon foundation absolutely draws a definitive line in the sand. It is ushering us fully out of the app era. We're officially stepping into the age of the personal AI computer. We're moving from a relationship of clicking and typing to one of true collaboration. I guess the only question left is, when your computer can finally do the heavy lifting for you, what are you going to do with all the time you get back? Thank you so much for exploring this fascinating paradigm shift with us. For more, visit our website, ferrussolution.live.